Now, I know at the end of the last video, we said we'd make sure all the data was filled up, like there were no missing values. But after reviewing it, I think it makes a little bit more sense to make sure it's all numerical first. So let's make a little heading. We'll call this 1.1. Make sure it's all numerical. Wonderful. And now, to begin with, we kind of need another data set. Now, why is that? Well, because our heart disease data set, this one here, is already all numerical. So, that being said, let's import another data set, which is our trusty car sales data. Now, if you remember this right at the start, I've kind of revealed a little bit here, but this one only has 10 rows. And what I've done is I've gone and manufactured a little extended version of this, which has the same headings, make, color, odometer, doors, and price, but this time we've got 1,000 rows. I'm not going to scroll through them because that would take too long. You're just going to have to trust me on that. Anyway, I can prove it. Car sales, let's import it. pd.read.csv. Remember, I've moved all of our CSV folders into a data file, which is kind of best practice. Keep your working directory tidy. Car sales extended.csv. Wonderful. Then we're going to have a look at it. Car sales.head. Wonderful. And then we'll figure out how many there are. 1,000. Beautiful. Told you so. And then we'll look at the data types. Make is an object, color is an object, odometer, doors, and price are all integers. And now these are objects because they're strings and they are categories, whereas these are numerical values. Now what we have to do, because this section is make sure it's all numerical, is before we can run a machine learning model, we have to convert these to numbers. But just to prove it, let's try anyway and see what happens. So first of all, what we're going to do is split the data into X and Y. So we'll use these 4 columns, make, color, odometer, doors, well not price, but these 4 to try and predict the price of a car. Now have a think to yourself, does this actually make sense? Could you do that in real life? Do we expect our machine learning model to do well on this kind of problem? If you were given only the make, so Honda, the color, a white Honda, with 35,431 kilometers on the odometer and 4 doors, could you predict the price was $15,323? Maybe, maybe not, but you probably need a little bit more information. The same probably goes with our machine learning model. But nonetheless, let's try and make one. So split into X, Y, which is, we want the feature matrix. So we're going to go X equals car sales dot drop. Now we don't want the price column. Oh, what have I done? Accidentally press Shift Enter. I'm getting very trigger happy in this notebook. Price axis equals 1. And we're going to do Y equals car sales. Now this is going to be just the price column because we want to use the X to predict the Y. And then we'll also split into training and test set. Split into training and test. So do X train, X test, Y train, Y test equals, we saw this before, train test split. We'll pass it X, we'll pass it Y, and we'll pass it test size equals, we'll use 20% of the rows for the test data set. Wonderful. Well, let's try to build a machine learning model that'll learn on the training data, so the X train and the Y train, and then predict on the test data. All right, build machine learning model. Now this time we're going to use still a random forest, but I want you to guess what this random forest can be used for. So we're going from sklearn ensemble import random forest regressor. Now if you remember back in our workflow, we were predicting a classification problem. Now this random forest regressor is the same as a classifier random forest, but this time it can predict a number, which is what we're trying to do, right? We're trying to predict the price of a car given some attributes about it. So we're going to import a regression model and we're going to set it up. This time instead of calling it CLF, we'll call it model regressor. Beautiful. And then we'll go model.fit. We want to train it on the training data. So it's going to learn the patterns, the relationships between the X variables and the price, the label. And then we're going to score it, evaluate it on the test data. y test. Now, how beautiful is that? This is the power of sklearn, right? We can create a model, train it, and run it, evaluate it, in 4 lines of code. We could really do it in less, but 4 lines of code is pretty damn good to build a full-blown machine learning model. So let's do it. Oh no, we got an error. What's happened? Value error. We kind of expected this though, right? Value error. Could not convert string to float. Nissan. Ah, now we see what's happened. Is that our machine learning model can't deal with strings. So, as we kind of knew, we have to convert these into numbers. So let's see how we do that with sklearn. Now we're going to kind of go through this little chunk of turning the categories, make and color, into numbers with sklearn. And it might seem like a bit to take in to begin with, but we'll write it out, we'll see the code in action, and then we'll go back through it and see what it's actually doing. So from sklearn.preprocessing, sklearn has a fair few modules that each do a number of different things. One-hot encoder. Ooh, what's that? We haven't seen that before. We'll put a little comment on here what we're going to do. Turn the categories into numbers. Wonderful. From sklearn.compose, import column transformer. Oh, I wonder what that does. You can probably kind of guess what column transformer does, but we'll see it in action first. Then we're going to define our categorical features. So in our case, our categorical features are make, color, and a tricky one is doors. Now, you might be thinking, why doors? Let's go back up, have a look at it. Doors, 4, 5, 4, 4, 3. Why is this? Well, let's see it. Car sales, doors, dot value counts. It's safe to assume that doors is numerical, right? Because we've got 4, 5, and 3 as the values. But it's also categorical, because you could go cars with 4 doors fit into this category, cars with 5 doors fit into this category, so there's 79 of them, and cars with 3 doors fit into this category, so there's 65 of those. So we're going to, in our case, treat doors as categorical. And I'm just continually spamming Command S so the notebook saves. It's like I've ingrained it into habit, just like pressing Shift and Enter to run a cell. So we've got 3 categorical features. Beautiful. And then we're going to make this little variable called one-hot. We're going to take in advantage of the one-hot encoder class that we've imported. So we'll instantiate that there. Then we're going to make a little variable called transformer. And then this one is going to use the column transformer. This is going to accept a list of tuples with a name. So in this case, we'll call it one-hot. And then we'll pass the actual transformer that we want to use, which is the one-hot variable that we've just instantiated. We're going to format this to make sure it's nice spacing. And we're going to pass it the list of features we'd like to transform. And then finally, oh, we don't need that. Let's bring that back up. Got stuff all over the place here. Bring that back up. Wonderful. And then here we're going to pass one final variable or parameter to column transformer called remainder equals pass through. Beautiful. And then we're going to have a little variable here called transformed x, which is basically going to be the version of our x data. Let's have a look at what x is. Basically, transformed x, we don't want all of those, is going to be the version of this, except converted into numbers. So let's see that. So we've got our transformer here. This is where we're going to go transform.fit transform on x. And then we're going to have a look at transformed x. Oh, we got some invalid syntax. Oh, got a comma here. Name error. Transform is not defined. Classic. Transformer. There we go. Wonderful. So this is spitting out an array. Maybe if we put this into a data frame, that would make sense. So let's go pd.dataframe. See if we can actually. Transformed x. Wonderful. So you might be looking at this going, what the hell is this? But if we bring back x, what we're going to see, dot head, we're working a bit zoomed in, so we're going to have to kind of keep bouncing up and down a little. But what has happened is that because we've told scikit-learn that, hey, make, color, and doors are categories, what this code here has done has transformed it, specifically one-hot encoded it. So now we've converted the make, color, and doors columns into one-hot encoded variables, but the odometer column, so which is here, you can see the numbers are actually the same still. So 35431, yep. 192714, yep, correct. So the odometer column hasn't been changed. So if we look back up here, the reason why make, color, and doors have been changed is because we defined them here. We instantiated a one-hot encoder. We'll see what that is in a moment. Then we've created a transformer using column transformer. So basically this is saying, hey, column transformer, take the one-hot encoder and apply it to the categorical features, and for the remainder of the columns that you find, pass through. Don't do anything to those. And then what we've done is created transformed X and fit our transformer, so fit transform, to our X data. Now that's a kind of a big of a mouthful there, and you might be thinking, what does one-hot encoding even mean? Well, let's have a look. We'll go to our keynote. So this is one-hot encoding in a nutshell. If we have 4 cars, so cars 0, 1, 2, 3, and their colors are red, green, blue, and red. If we wanted to one-hot encode these, so basically turn the categories into numbers, it would look something like this. This is what one-hot encoding does. We've got car 0, and because the color of car 0 is red, this little arrow here could be the code that we've used to transform our data frame. So to transform our categories into numbers. So this is one-hot encoding. So because car 0, the color is red, it gets a 1, and it gets a 0 for the other 2 categories. And the same for green. But this time, because it's green, it gets a 0 for red and a 1 for green and a 0 for blue. Blue, exactly the same. 0 for red, 0 for green, and a 1 for blue because it's a blue car. And then finally, because car 3 is also red, it has a 1, just like car 0, and there's 0 and 0 for green and blue. Now that's what we've done here, except not only with the color column, we've done it with the make and the doors columns. So that's why we have 0, 1, 2, all the way up to 11 features with zeros and ones now. What we've done is we've encoded the different parameters of each sample, so Honda, white, and number of doors, into zeros or ones. So now the beautiful thing is, our data is all numerical. So what can we do? Well, we should be able to fit a model. But just in case that wasn't clear, we've got one more way that we can do this. And now, so that we can go dummies equals, there's a function in pandas called getDummies, which is kind of like one-hot encoding, but I'm actually not sure why it's called dummies. I just know that the function is getDummies. So if we go dummies, pd.getDummies, and we want to transform car sales, we pass a list of the columns that we want to transform or turn into dummies. So here, doors. Now let's have a look at dummies. Here we go. So I think because doors is numerical, it hasn't worked on here, but this is what we can see what's happening. So we've got 0. Make BMW is 0, so it's a Honda. It's got 0 for Nissan, 0 for Toyota, and it's got zeros for black, blue, green, red, and white. So if we went through this, all it's done is turn the make and the color into zeros and ones. Beautiful. So now that our data is all in zeros and ones, let's try and refit the model. So we want to go np.random.seed. We got 42 just so our results are reproducible. We're going to use X transformed up here. So this one here instead of X. So let's do that. X train, we'll set up a new training and test data equals train test split. And we're going to pass it transformed X, and Y can stay the same because Y is already numerical. And then we're going to have test size equals 0.2. Excellent. And then we can go model.fit X train, Y train. Beautiful. It worked. And now let's evaluate it. Model.score X test, Y test. Wonderful. Now, it worked, right? So because we used transformed X, and because up here we did this little bit of code here to transform our data from being categorical into numerical, and previously our model could not convert floats to, or strings to floats for Nissan, so when we used our first X variable up here, our data was still in categorical form, so still using strings to represent a sample. And what happened? It errored out, got a value error. But now, right down here, when we run the same code, model.fit xtrain ytrain, and score, we don't get any errors. Why? Because our data is all numerical. Now, as for this score here, if we imagine the best score you can get is 1.0, the model probably hasn't done it as well as it could possibly do. But remember, we talked about that. If you were to look at this data here, the X data, and you were trying to use this to predict a car's price, it will probably be pretty hard. So maybe the model has found some patterns, but they just weren't that great because there wasn't too much information about each sample. But that's not the point. We can look into evaluation metrics later. The point here is that we've converted our data, from being non-numerical to completely numerical, and that has allowed us to fit a machine learning model on it. Now we've covered that, we've converted all our data to numbers. What happens if there was missing values? Let's check it out in the next video.